Hello students and welcome to the new lecture session. Myself Shankhu Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandrasud Degree Engineering College under the JIS group. Today we'll discuss a topic that name is thermography. This is the module number 7 of the subject of non-destructive testing and application, which is the 7th semester automobile engineering students subjects. So students, in thermography, this is another type of non-destructive testing methods. So here the objective of this class, of today's class, is that we can understand about the thermography, its definition, the basic principle which belongs on it, and on this topic we also discuss the various types of equipment which are used for this thermography testing. What is the block diagram? Describe its block diagram, its different types of techniques and their application also. So students, let's start the today's class on the topics of thermography. So let's start it. Thermographic inspection. Thermographic inspection refers to the non-destructive testing of parts, materials, or systems through the imaging of the thermal patterns at the object's surface. So students, basically this thermographic inspection refer the imaging on the thermal pattern of object surface by the non-destructive testings on different type of parts, material, and the systems. This testing is a contact-free predictive maintenance method. This testing is a contact-free predictive maintenance method which is used to detect connection of defects, systems overloads, deteriorated insulation and other potential problem in mechanical or electrical components. So this testing is basically a contact-free predictive maintenance. In previous lecture, which we already discussed on the various types of non-destructive testing methods like visual testing, liquid penetration testing, magnetic particle testing, ultrasonic testing, so on. So all of these are contact testing, means the equipment is contact with the object and then testing. But here this thermographic testing is totally a contact-free predictive maintenance method. This is specially used for detecting the connections of defects, systems overloads, deteriorated insulations, and other potential problems in mechanical or electrical components. For instance, the application of temperature sensitive coating to a surface in order temperature sensitive coating to a surface in order to measure its temperature is a thermographic inspection contact technique based on heat conduction where there is no infrared sensor involved. This technique also known as the infrared inspection also. So this infrared thermography is used to find the area. This infrared thermography is used to find the area of excess heat so that problem can be corrected before they lead to excess power uses. So the problem can be corrected before they lead to excess power of uses and increase the maintenance cost with different type of service interruptions, catastrophic equipment failure and or equipment damage. So students, to protect the increasing the maintenance cost, service interruption, catastrophic equipment failure and equipment damage to correct it by the infrared thermography. This infrared thermography is a non-destructive, non-intrusive, non-contact mapping of thermal patterns or the thermograms on the surface of objects through the use of some kind of infrared detector. So these are the basics of this thermography. Now student discuss. I'm ready to discuss about the infrared thermography. Infrared thermography at ambient temperature and above this at ambient temperatures and above these are predominantly infrared radiation. There is the infrared radiation which is known also IR. This IR invisible to eye but with the aid of a suitable detector IR can be converted into the visible range. IR can be converted into a visible image. Variation in the temperature of the surface. The variation in the temperature of the surface of the object can be visualized from the thermal image of an object. So this means that deviation from the normal temperature can be detected from a distance. So this infrared thermography. So the students, the infrared thermography is a surface thermal radiation measurement techniques. Infrared thermography is a surface thermal radiation temperature the radiation measurement technique which is used to detect spatial radiation, which is used to detect the spatial variation in the measured surface temperature pattern. This infrared thermography is used to detect the spatial variation in the measured surface temperature pattern. So in this technique widely applied in different fields. This technique, this integrated thermography technique is widely applied in the different fields such as military, space, astronomy, environment, medical or bioscience, and also the commercial application too. The advantages of infrared thermography. The advantages of infrared thermography are that is provide non-contact, full field, fast inspection speed, easy interpretation from thermogram. So the advantages of this infrared thermography are that it provides non-contact, full field, fast inspection speed, easy interpretation from the thermogram, and it is suitable for metal or non-metal materials too. In this laboratory, this technique is employed. This technique is employed in the non-destructive testing method for the quality inspection, condition monitoring, and other research and development in the application. The basics of this infrared thermography. Here the picture shows the variation of the wavelength, where the wavelength is vary from 1 kilometer to the 1 nanometer, 0.1 nanometer, and there are various zones. So this in between frequency, the wavelength lie on the AM. In between the 1 meter and 10th meter, the frequency lie on TV and FM. In between 1 millimeter to 1 meter, the wavelength vary for the microwaves. In between 1 millimeter to 1 micrometer, the wavelength is vary with the visible radiation and the infrared. In between the 1 micrometer to 10 nanometer is ultraviolet wavelength. 1 nanometer to 0.1 nanometer it is X-ray. So here, if I go for this point to this point, this is the wavelength which is for this particular area, but this is the area which is visible to the naked eye. The human can see these lights within this wavelength, and otherwise they cannot understand this wavelength. But there is an infrared radiation which is totally invisible to the human eye. So this wavelength belongs in various portions, that is short wave, medium wave, and the long wave. In between 0.9 to 1.7 micrometer, in between 0.9 to 1.7 micrometer, the short wave is created. In between 1.0 to 5.0 micrometer, medium wave is created, and in between 8.0 to 13.0, the long wave is created. So these are the pictures of, this is the picture for the variation of different type of wavelength. Now we'll discuss on the history. In the year of 1800, the infrared The infrared was discovered. The infrared was discovered by Sir William Herschel. Sorry. In the year of 1800, infrared was discovered. Infrared was discovered by the Sir William Herschel, who is the royal astronomer. When dispersing the sunlight, dispersing the sunlight using a prism, accidentally Herschel accidentally found that there was an invisible light. There was an invisible light on the outside of red light. There is an invisible light which is outside from the red light when increases the temperature of an object. When increases temperature of an object. So this is the history of this infrared. Now coming to the characteristics of infrared. Before going to discuss the various topics, various things on it. So before it, we need to know about the characteristics of the infrared. It is invisible since its wavelength. The infrared is invisible since its wavelength is longer than the visible light. That is why infrared is invisible. So it has nothing to do with the brightness or darkness of visible light. It has nothing to do with the brightness or the darkness of visible light. It is emitted naturally from any object. It is emitted naturally from any object of which temperature is absolutely zero or higher. So students, this infrared ray which is emitted naturally, in form of any object which temperature is maybe zero or on or above. So it can be applied in any field. It has a characteristics of hitting an object. It is a kind of light. It is a kind of light which produces electromagnetic wave. It is a kind of light, invisible light, which is produce electromagnetic wave. It can transmit it through the vacuum. So it can be transmitted through the vacuum. There is a correlation in between the infrared energy and the temperature of an object. There is a correlation in between the infrared energy and the temperature of an object. It can be used to measure this infrared energy or temperature relation can be used to measure the temperature of an object. So these are the characteristics of infrared. Next one is heat transfer. So the heat transfer, when heat is transferred, via the solid material. When heat is transferred via the solid material, that is called conduction. When it is when heat is transferred to the liquid and the gases, then it is called the convection. And when the heat is transferred through the wave, then it is called the radiation. So basically heat is usually transferred in the combination of three types. So the heat is transferred in the combination of three types, that is conduction, convection and the emission. When heat is affected, this is the conduction, means heat is transferred through the solid material, so this is the conduction heat. When heat is moves from the solid to the gases, so this is called the convection method. When it goes to the air, then it is the emission or the infrared method. So students, basically heat is transferred in these three ways. So students, next is emission. The emissivity. The emissivity. This emissivity is defined as the ratio of radiation, the ratio of the radiance of a body at a given temperature to the corresponding radiation at a black body at the same temperature. This is the radiation. So emissivity, the emissivity of the surface of a material is its effectiveness in emitting energy as thermal radiation. The thermal radiation is an electromagnetic radiation. The thermal radiation is an electromagnetic radiation that may include both the visible radiation, that means light, and the infrared radiation, which is not visible for the human. So basically thermal radiation is the combination of visible radiation and the invisible radiation. That is why this thermal radiation is also known as the electromagnetic radiation. This thermal radiation from very hot objects is easily visible to the eye. The thermal radiation from the very hot object, which is easily visible to the eye. Quantitatively, emissivity is the ratio of the thermal radiation from a surface to the radiation from a ideal black surface at the same temperature as given by the StefanBoltzmann Law. The emissivity is the ratio of the thermal radiation from the surface to the radiation from an ideal black surface at the same temperature, which is given by the StefanBoltzmann Law. The ratio which varies from 0 to 1. The ratio which is vary from 0 to 1. The surface of a perfect black body. The surface of a perfect black body with an emissivity of 1, which has the emissivity 1. It emits, this perfect black body emits Thermal radiation emits thermal radiation at the rate of approximately 448 watts, approximately 448 watts per square meter at the room temperature, that is 25 degrees Celsius. All real objects have emissivity. All the real objects have the emissivity which is less than 1, and it emits radiation at correspondingly lower rates. It emits radiation at the correspondingly lower rate. So student, is the emissivity. Next one is each material which has a different emissivity. As I told, so the emissivity vary from 0 to 1, and for the perfect black body, the emissivity value is 1, and the other all the real object value is which is less than 1. So each material has different emissivity, which may vary for the different temperature or vary by the temperature and the infrared wavelength. So the emissivity of a material is different just because of two things. One is its temperature and is its infrared wavelength. For an example, clean the metal surface have emissivity that decreases. The clean metal surface have emissivity that decreases at longer wavelengths. Many dielectric materials that such as quartz, that means silicon oxides, calcium fluorides CaF2, aluminum oxide L2O3, etc. These have the emissivity which increases at the longer wavelength. Clean metal surface have emissivity that decreases at longer wavelength. Just because of the decrease in the wavelength, dielectric material have the emissivity just because of it increases the longer wavelength. And simple oxides such as iron oxide, that is Fe2O3, which is displayed relatively flat emissivity in the infrared spectrum. So these are the next is the principle of this infrared thermography. Infrared thermography is a thermal imaging technique. This thermography which is make use of the infrared spectral band. This thermography makes use of the infrared spectral band of the electromagnetic radiation. The infrared band is further subdivided. This infrared band is subdivided into the fourth category. First one is near infrared. The value of the near infrared is 0.75 to the 3 micrometer. 0.75 to the 3 micrometer. After the near infrared, next one is middle infrared. The value of middle infrared is vary from 3 to 6 micrometer. After the middle infrared, next one is far infrared, and its range is vary from ranges is started to from 6 to the 15 micrometer, that is far infrared. And next one is this extreme infrared. The value of is it's 15 to the 100 micrometer. The most commonly used band, the most commonly used band for the commercial of infrared imaging is in between 0.75 is in 0.75 to 15 micrometer. So the students, we are basically for this infrared image captured by the infrared camera, which detects the infrared light radiation that is near to 1 to the 14 micrometer, which is varies in between the infrared commercial infrared imaging. The property of infrared, the property of the infrared radiation are similar. The property of the infrared radiation are similar to those of electromagnetic radiation, such as visible light, except their transmission and absorption behavior is different from that of the visible light. This infrared radiation travel in straight line outward from the source, and they can propagate easily in vacuum and in certain liquids, solids and gases. They can be optically focused and directed by the lenses or mirror or displayed by the prism. This infrared can also be transmitted through the certain material which are opaque to the light. So this radiation distribution image can be converted into temperature scale, can be converted into the temperature scale and produce a temperature distribution which is image called as thermogram, according to the StefanBoltzmann law. Now the thermography allow us to see the variation in temperature. This thermography allow us to see the variation in temperature, since the amount of radiation emitted by an object increase or decrease corresponding to the change of this temperature. Here a variation of the color code. This is the white hot, this is black hot, this is fusion, this is the rainbow color, this is the glovo, iron bow 1, this is iron bow 2, this is the sepia. This is color 1, color 2, and this was the ice and fire, and this is the rain. Here for the black and hot, this black portion is cold and this white dot is hot. In the black hot, this white dot is cold and this black dot is hot. In this fusion, in this color coding, the black, in this black code is cold and this white code is for hot. In the similar way, there is in for rainbow there is a hot point and there is a cold point. So these are the variation of temperature which is color defined by the different type of color code. Next is StefanBoltzmann law. The StefanBoltzmann law statement that the total radiation, StefanBoltzmann law state that the total radiant heat power, emitted from a surface which is proportional to the fourth power of, is proportional to the fourth power of its absolute temperature. StefanBoltzmann law statement that the total radiant heat power emitted from a surface is proportional to the surface power of its absolute temperature, which is formulated in the year of 1879 by an Austrian physicist Joseph Stefan as a result of his experimental studies. This same law, which is derived in the year of 1884 after the 5 years by the Austrian physicist Ludwig Boltzmann from the thermographic consideration, and the equation looks like this, that is E equals to the sigma T to the power 4, where sigma is the Boltzmann constant, T is the absolute temperature, and E is the total radiant heat power. So this law is applied only on the black bodies, theoretical surface that absorb all the incident of heat radiation. Next is types of thermography. According to the different measurement of methodology, these techniques can be divided into the two types of inspection. One is passive and another one is passive thermography. The passive thermography directly measure the surface temperature for evolution, since the interest region will have abnormal hotspot as compared with the surrounding. An abnormal temperature profile indicates a potential problem where the keyword is temperature difference with respect to the surrounding. The features of interest are naturally at high or low temperature than the background. As you can see here, this is the material. Core material color is red, then yellow, then green, and then blue. Core material that is color of in red, joint layer that is colored in green, and the surface layer is colored in blue. And when there is no defect, so it looks like in this way, and if there is a defect, so that portion absorbed it and there is create a black spot. So these are the passive thermography. Here is see a picture of a building, which is in this way. When we use a thermal measure, so we can see this building looks like this way. So this is the thermography. Next is the passive thermography. This is active thermography. Active thermography measure the surface temperature for evolution after applying the thermal excitation, and thermal and external energy sources is required to produce a thermal contrast between the feature of interest and the background, since the inspect parts are usually in equilibrium with the surrounding. The defects can be detected by the flaw of anomalous and the heat transfer response with the considering the factor of time evolution after the applied the thermal excitation. Here is a picture of this. This is a material where there is no defect. The heat radiation looks like in this way. If there is a defect, so this is the high peak. So in this way you can find out the active thermography. Now there is a various types of thermography, that is pulse thermography, transient thermography, lock-in thermography, and vibrathermography. These are all details in the next class. So students, today's class will learn about the thermography, infrared thermography. You can understand about the infrared thermography, their characteristics, the principle of the thermography, the various types of, that means active thermography and the passive thermography. Then we can easily understand the emissivity and the StefanBoltzmann law. So student, in the next part of this thermography class, we discuss the next part. We discuss in the next class. So still then, stay at home and stay safe. Thank you so much.